Hey there, fellow coders. Welcome back to our series on running Apache Airflow on Kubernetes. I'm Praj, and in today's video, we are going to explore how to monitor your Airflow environment using logs and metrics. Monitoring is essential for any data pipeline, and anyone with experience in software development understands its importance. If a DAG fails or task starts lagging, you need to catch those issues immediately. Logging provides real-time insight for each component and captures errors, including stack traces, that greatly simplify debugging. Meanwhile, Prometheus and Grafana track performance metrics over time, helping you spot bottlenecks or system degradation. We are going to use Prometheus and Grafana in this video, but there are numerous tools out there that can help track metrics. Let's start with logging. For this video, we are only going to use Stern, which is a tool that allows us to tail logs for Kubernetes pods. It gives us some extras as compared to good old Kubernetes logs, like color highlighting according to pods, and also has the ability to trail multiple pods in one command. For monitoring, as I said earlier, we will be setting up Grafana and Prometheus in our local Kubernetes cluster. We'll try to stick with infrastructure as code best practices as much as possible in this exercise too, with which it would be really easy for you to get everything up and running right from the configs provided in the GitHub repo linked in the description below. For monitoring Airflow, we'll modify Airflow's chart values YAML file with some extra properties needed for statsd. Once we have all the Airflow metrics flowing in, we will also look at adding Kubernetes monitoring so that we can keep an eye out on Kubernetes cluster health, thereby allowing us a better insight into tuning the number of tasks we can run in our Airflow DAGs. To install Stern on a Mac, all you have to do is run brew install Stern, and that would install the package for you. Now for this video, we are going to look at a simple example to see all the pod logs, which we wrote in one of our earlier videos, whose link should pop up in the top right. We had written a DAG for testing out parallelism settings in MWAA. The code for that DAG is available in the GitHub repo, which I'll link in the description below. What we are going to do is we are going to run that DAG and keep an eye out on the logs that are emitted. So to run that DAG, let's head on to the browser, localhost 8080. Here we go. Our Airflow web UI. Now what we are going to do is just trigger this DAG. Now that we have triggered this, let's go back to the command line and let's run stern. The name of this is add1, so it's going to be like the pod name would be test parallelism underscore add1. So that's what we'll do. Test parallelism add1. Okay, my bad, it's not underscore, it's actually a hyphen. So if we run this, notice that like using stern, the more like pods the Airflow is starting up, it's actually showing all of them over here. If you take a closer look at this pod as an example, it's going to run git sync first, and after running git sync, it moves forward to run the other pieces of the task. This git sync, as we covered earlier, what it does is it basically pulls down the code from Git and loads that onto the pod. Now, Stern is a great tool to look at logs while developing, and also to look at logs when they are not indexed by a logging platform. Whenever we collect logs, remember that we are actually spending money to index them and making them searchable. Yes, there are a few platforms which are more cost effective than others, but the point I'm trying to make over here is there would come a time when you have to ignore persisting some logs to save money. And that's where Stern is a great tool to have in the pocket to look at all the logs the pod has in real time if you have access to the Kubernetes cluster itself. Next step for us is exporting metrics. Airflow's Helm chart already has configured statsd exporter pod for us. So if we do Kubernetes Airflow and then do kubectl get pods grep for stats d. You can see that the pod is already running. To look at the metrics that Airflow Stats D provides us out of the box, what we could do is we could port forward using something like this, and then head on to the browser. So if we do localhost and then 9102, we can see all the metrics that StatsD would provide us. As you know, like StatsD would like keep on refreshing this, or Airflow would keep on refreshing this at certain certain interval. So what we need to do is ask Prometheus to actually scrape all these metrics and store it in Prometheus. So what we are going to end up doing is we are now going to install Prometheus using the instructions provided in the GitHub repo. I've already linked this in the description below. So first you're going to end up running this Helm repo add, which just adds the Prometheus community repository to Helm, and you'll do the same with Grafana. Grafana is just a UI which can show all the data that's available in Prometheus. So think of Grafana as something similar to Kibana if you're familiar with the Elastic Stack. Then, like, before actually installing both of these, let's first actually go in to the values file and update these so that Prometheus actually scrapes the statsd containers, and then Grafana can actually connect to the Prometheus container. Cool. Let's start with Prometheus first. Let's search for statsd, and here you can see that I've already added the job for scraping, and this is the target that I already have set up. So Airflow sets this up automatically. I didn't have to do anything for this. All I did was I stitched together the service using kubedns, and then just added the port in front of it. Now that we have Prometheus set up to scrape statsd, let's go into Grafana and set up data source for it. So if you search for data sources, you can see that I've added Prometheus. Grafana's default values template already had Prometheus type setup. All I did was I changed the URL according to what I have. Same as I did earlier, I just stitched this together using what kubedns has. Now that we have both of them running, let's just expose the Grafana service. So if you run this command, let me do this, copy right over here. If you run this command, what this is doing is it's changing the type of Grafana's service to be node port, and then changing the target port of the service to be 3000. Now if I do Kubernetes monitoring first, and then kubectl get services, you can see that service for Grafana is now a node port and would be available at 32022. Now when you are logging into Grafana first, you will also need a secret which the Grafana chart automatically creates for us. So you would need to run this command. Okay, seems I have an issue in the command. I'm going to fix that in the README. It's basically, I'll have to do monitoring. Now because I have pb copy at the end, it's directly copying into my clipboard. Now let's go to Grafana. Good part about Grafana is because it's community driven, there are a lot of open source dashboards available to us. So what I ended up doing was I searched dashboards in Grafana's library, and I found this one which was interesting. So I just copied the dashboard ID. I went ahead in dashboards, went to new, import, then pasted the copied dashboard ID, hit on click. It's already there, so I'm not going to do that again. But basically, like, all you'll have to do is update your Prometheus data source and just hit import, and that would add the data source for you. If you go into the dashboard itself, you'll see a bunch of data that's already present because I already like ran the DAG a couple of times, and plus you have like some scheduler heartbeat and like stuff like that already present over here. Now you can see that there are a bunch of other options which don't have data or just like are showing 0. The reason that's the case is because like if you hit edit, you can see that it's basically just it's actually filtering out some values. I'm actually not going to like fix all these in this video. I just wanted to show how to set Grafana up. So what I'll do is I'll fix this chart according to the metrics that we have, and I'll also like update that chart in the GitHub repo so that by next week you will have this chart ready to play around with. And when we actually look at trying to optimize our DAG, at that time we'll have all the values giving us all the required insights into our Airflow cluster. For the next step, we are going to install kube state metrics so that we can actually capture all the Kubernetes like state metrics and push them onto our Prometheus pod. Next up, what we are going to do is we are going to install kube state metrics onto our Kubernetes cluster and then ask Prometheus to scrape those metrics. Now, to install Kubernetes state metrics, what you have to do is there are multiple ways in which you could install kube state metrics because it is a widely used tool, and there are like different providers allowing you to install this. I went ahead with Bitnami as like I found it easy to install. What I'm doing is I'm just adding the Bitnami repo, charts repo, and then I'm going to install the kube state metrics chart, and I'm going to install that in kube system namespace because that's where generally all the Kubernetes system pods would end up, or system related services pods and any other resources end up. I actually went ahead and ran all these three, so I already, if I go into kube system and do get pods, you can see that I already have metrics server running for me. Now what I'm going to do is I'm going to take a look at what services I have in kube system. Kube system, get services, and I have the metric server service available for me. Now to install or to ask Prometheus to actually scrape this, what I'm going to do is I'm going to do Prometheus. Let's go to data. Let me make this bigger so that you can see the whole screen. Let's go to our data sources. Oh, my bad. In Prometheus it's going to be scrape and not data sources. So scrape, so that's the already had this scrape configs. I'm going to add job name to be, let's say, kube state metrics static configs. It's going to be our targets and then the address. Okay, we could do is going to go back to this window, save the readme, kubectl get services in kube system namespace, Oops. Now the as I told you earlier that Kube DNS follows a certain pattern using which it exposes all the services to us. So I'm going to just add this on the fly. Metrics server, then the namespace is Kube system. So it's going to be Kube system dot svc cluster dot local, and that's the because it's 443, you don't have to like add anything over here, or might as well. Let's see, writing this out now. Let me install Prometheus again. Install Prometheus. Now that I have Prometheus installed, I'm not going to pay attention to the warnings because this is not my production system, so I'm just going to ignore this. Now let's head on to the dashboards and create a new dashboard for this. So I'm going to go back to Grafana dashboards and search for Cube System Metrics V2. This seems to be a good one. I'm hoping everything would be in English. It seems to be provided by Grafana Lab Solution. I copied it over. Now let's import. Load. The data source is going to be Prometheus. We can see that all the Cube state metrics are already being loaded over here. We can see the number of nodes we have because we are only running one node on our local machine. That's what we can see, and everything else is available over here out of the box. So as you can see, it's pretty easy to set up. Now we don't have it like any horizontal pod auto scaling setup, so we can ignore this. As you can see, it's very easy to set this up locally and get everything up and running. Let's recap on what we covered today. We used Turn to take a look at real-time logs. We could have used Elasticstack, but I decided against it for this video to avoid covering a lot of topics. Let me know if you are interested in the comments below, and I can make a separate video for that. Then we looked at Prometheus and Grafana as our metrics collecting and visualization solution, and also looked at installing and setting up Cube state metrics. We are now all set to play around with tuning Airflow DAG itself. Before parting, I wanted to touch on a few things that you should keep in mind. As I had said earlier, we are not using any hosted service to run our stack anymore. So we are responsible for its performance, size, and security. If you are using Prometheus to store a lot of metrics, it needs to be sized accordingly. We are also responsible for its security and making sure that the sensitive data doesn't get into logs or gets publicly exposed. The last point would deal with data sizing and cost of storing plus indexing the data. If you end up with a lot of data in your storage, then you would end up paying a lot more for it, as well as your dashboard performance might take a hit. So keep these things in mind. We'll talk more about this when we chat about the tips for running these systems in production in a later video. Thank you for listening to this video. If you found this helpful, hit like, subscribe, and leave your comments and questions in the comment section below. In the next video, we're going to take a look at tuning our DAG to make sure that it runs faster and see which of the metrics actually play a role in that. See you soon and happy coding.